So within this video, then we're just going to look at angles, just do angle facts, and then also anything how we can then start to apply them. So some of the things you might get asked is very much a case of what is this angle? So right here, what we've got here is a 90-degree angle, but what it is called is a right angled not right angle, just a right angle. Okay. The next thing here for B, we've got that this is greater than 180 degrees, and this is a reflex angle. Over here, we've got an obtuse, and on here, we've got an acute angle. Okay, so up here, then we've got them labeled, so then we can then put the letters then within this box. So acute angle, which said was D. Obtuse angle, we said was C. Right angle is A, and then a reflex angle is B. So thinking about some of these facts here then, so an acute angle is always less than 90 degrees. Okay, so anything less than 90 degrees is an acute. An obtuse angle is anything that is greater than 90 degrees, but less than 180 degrees. A right angle will always be 90 degrees, and it will always stay as 90 degrees. A reflex angle is greater than 180 degrees, but less than 360 degrees. Okay, so from anything from 181 through to 359. Putting that sort of angle stuff into practice. So what we've got here is I can see 122 is an obtuse angle. And then I can see that that is less than 90 degrees. So I know this is an acute angle, but it's also asking me for the size. So one of the angles that then we need to know about again is then what does that equal to in total? Well, that equals to 180 degrees. So a straight line always equals to 180 degrees in total. Okay, and the reason for that is if you've got a full turn or angles around a point, when you put a nice straight line through the center of the circle, so think about circle knowledge, nice diameter there. We've then got 180 degrees on top, 180 degrees on the bottom. So to work out X, we'd do 180 degrees, subtract 121 degrees. So do a bit of borrowing, 9, 5, 0, so 59 degrees. And because I saw that it was an acute angle, that's now confirmed by that 59 because I can see that that's less than 90 degrees. Other facts then we can look at is an acute angle and an obtuse angle can make a straight line. Would never get two obtuse angles together making a straight line. So if they ask us for some of those sort of facts, we can then start to think about some of those knowledge bits that we know, how can we start to apply? Next one then, question 5. We've got angles around a point. So angles around a point, just like the little diagram here, makes a full turn in total, so a circle. You know, even though there's a right angle there, it's still all the way around. We know that from that mathematical symbol of a little square, we know that this is 90 degrees, and in total, a full turn is equal to 360 degrees. So I've now got to do a little bit of adding first. Gives me 235 degrees, and then again, just simplify, subtract it off to then give us 125 degrees. So X equals 125. If we look at that again, if we look at the actual size of it, that looks like an obtuse angle because it's bigger than 90, but not as big as a straight line. 125 is within 90 and 180 range. So again, it matches up. So I'm just trying to think about those angle facts and then what I look at. I'm going to skip through to number 7 now on that booklet. Got some triangle knowledge. So for a triangle, if you took each of the corners, the interior angles of a triangle, when you put them together, it would make a straight line angle. So the angles inside a triangle equals to 180 degrees. It's also told me that I've got an isosceles triangle. So I've got two sides that are the same, but also I've got two angles that are the same, which are these two angles at the bottom. So where you follow your arms down, those two angles at the bottom will be equal. So now I've got 65 degrees, add 65 degrees, gives me 130 degrees, 180 total, subtract off the angles that I know, 0, 5, 0, so x is equal to 50 degrees. And again, if we look at it, smaller than 90, job's a good one, it's an acute angle, 50 is an acute angle. It shouldn't have any dramas with that one, looked at that one. So we've got here now, zoom in a bit more, see if that works a bit. Right, so the diagram shows a square. So square, straight away, I'm going to start labeling things that I know. Okay, I've got these 90-degree angles are bisected, but what I need to know is if they are in half or not. It also says I've got an equilateral triangle. So what I've got here then is an equilateral triangle with 3 equal angles, all of 60 degrees. It says write down the size of angle ABC. So at point B is where my angle will be. So I've got A, B, D. So my angle here, A to B to D, is 90 degrees. It then says B, C, D. So I've got B, C, D. So I've already labeled it. So I've got 60 degrees. So notice that where the middle letter is where we're finding this angle we're looking for. And now I need A, D, and C. A, D, and C. So I've got this now, and I only want this part of the angle. So I know this part's going to be 60 degrees. I've got 90 degrees, and because I'm going corner to corner, that is then bisected. So I now know that that is 45 degrees because it's got that nice diagonal. Okay, what I've also got is, if I know that this is a right angle and I know this is a square, these two sides are the same, meaning that these two angles are going to be the same because it's an isosceles triangle. And then I've got my hypotenuse as the longer side there. So then I know that these are 45 and 45 is 90, add the other 90, 180 for that triangle. So to then just get those two parts for the angle ADC, I need 45, add the 60, gives me 105 degrees for that angle at that point. Right, turn over. Okay, so we've got some angles around a point. We should be okay with that. That we should be okay with. We look at a couple of these ones. So it says ABC is a straight line. Work out the size of B, D, C. So I need this angle up here. Okay, at the minute, I don't know that angle. I don't know what this angle is, but I do know that one. So at the minute, I can't use that angles in a triangle equals to 180. But if I do ignore that triangle, so if I covered that up and I just looked at that triangle, I've got an isosceles triangle. Okay, follow the arms down to the feet. The feet down here are the two angles that are the same. I've already used 70. So I've got 180, subtract 70, gives me 110. that's what both of those angles are worth together. So I now need to split them equally in half. So divide it by 2. So I've got 5, 5. So I've got both angles here of 55 degrees. Okay. Now I can then start to look at this part here. And because the question says that this line is straight, I know that where we've cut this line in half here, this is still a straight line. So for this angle, I've got 180 degrees, subtract 55 degrees. So 7, 10, so I've got 5, 2. So I now know that that's 125 degrees. Now I can now work out this angle because it's the only one that's left, but also I've got 2 angles out of the 3 in a triangle. So add the 2 angles that I know currently. So I've got 14, 5, 1, and then 180, subtract off 154. So I've got 7, so I've got 6, 2, 0. So this angle here is 26 degrees. So them 2 angles together was my 154. The 3 angles together equals to 180 with that extra 26 by doing the subtraction. Right. Next angle stuff to look at now is angles on parallel lines. And then also we've got an extra thing that's called vertically opposite angles. And this is where this first bit comes. So these are vertically opposite angles, and that's what we would have to use. So in the reasoning, we would write vertically opposite angles are equal in size. So if 53 is here, X is also 53 degrees. We now want to find out what Y is. Okay, in the question, it tells us that these lines here are parallel. This is your transversal line. Your transversal line is the line that cuts across your parallel lines, and it can come across at any angle whatsoever. We know these 2 are parallel because we've got the arrows. Okay, sometimes they can be just like that, but an arrow just depicts that they're parallel. So we want Y. So Y is 53 degrees also. Okay, effectively what's happening is if we cut that out, copy and paste it, it makes that zone down there. So it is all the way down. But what we've got to do is now give it an example using some angle facts. So we're going to draw one of these Z's in. Okay. These are on, and here's the key word, alternative sides of the transversal line. So they're on, alternative means opposite sides. So you've got one on the right, one on the left. When they're on alternative sides, they are equal in size. And again, copy and paste because it's just a repeat, top and bottom. So we've got to then use the word alternate because of this Z-shaped angle. So alternate angles are equal in size. Okay, if we have a look at this next one, this is a nice diagram just to show that effectively, look, A and C are equal, G and E are equal, D and F are the same as B and 110. So I know that that's 110. I know this is 110, and I know this is 110. And again, copy and paste down. What I also know that because this is a straight line, A add B is equal to 180 degrees. But also this is a straight line as well. So B add C is a straight line angle. 110 add C is a straight line angle. Okay, so we've got again a straight line and a straight line this side. So we've got other bits of knowledge that we can then use. I now know, though, because these two equal to 180, that's 70, meaning that's 70, that's 70, and that's 70. And that we can see that the pairs 180, 180, 180, 180, vertically opposite are equals. Copy and paste. Okay, so we can now look at what it's asking us to do. So AB and then CD are parallel. Again, we've got our arrows. Write down the letter of one of the other 110s. So I could now use either B, D, or F. I only need one of them, but any of those ones. Give you reasons. And again, this one, vertically opposite angles are equal in size. If you think about this why vertically opposite is, if we get these two pens and cross them, at this point where they're crossing, as you open them, the angles left and right are closing and opening in exactly the same amount. At the same point, top and bottom are closing and opening at the same amount. Okay, so they're moving together, and that's why then they're vertically opposite. We look at the next question down. Give a little focus. We've got parallel lines. Okay, we can then think about, right, this is vertically opposite. Okay, that's vertically opposite. We've got X over here, that's vertically opposite. I've not done anything other than start to think about what I've got. I could then start thinking about angles on straight lines as well. But before I jump too much into that, let's see what it's asking us to do. So parallel, find the size of angle X. So I need this angle. Okay. Give a reason for your answer. So I'm going to look and see if I think about this transversal line here. Effectively, I don't need any of this information as such, because everything that's up here is going to copy down here. So if I know that that's 32 degrees and that's 32 degrees, I can then start to look at that angle there. Okay, so I could use that and go, right, I've got 180 degrees, subtract 32 degrees. So I've got 7, so I've got 8, 4, so I've got, I know that that's 148 degrees. Now what I'd need to do is look at my answer for the second part to then think about how am I going to just give a reason. So we could talk about vertically opposite angles are equal, and then also you've got straight lines, but you've also got this angle here, and this is just a one-time explanation. So I've got now this angle here and this angle here are corresponding. They are both on the same side of the parallel line. So corresponding meaning the same. Same with these these 32s. So this is underneath, this is underneath. So I've got angles on a straight line with the corresponding angle is one explanation, or I've got vertically opposite angles and straight line angles are equal to 180. So I've got two things that I can then talk about, either corresponding and vertically opposite, or vertically opposite and straight line angles. Okay, in either of those would get you those marks using those angle facts. We go over again, starting to get a bit more into some of this nitty gritty. So we've got 3 markers, 3 markers to have a look at. So straight away we've got parallelogram. It's also telling us we've got a straight line angle. I can also see up here I've got a triangle. So I've got parallel sides here. I've got a transversal line if I need them, but they're also parallel to each other. And I've also got a nice straight line. Where is it? I've got, yeah, B, C, and E together. So that's a nice straight line. So I'm thinking 180 degrees here. Parallelogram, I know, is 360 because it's a quadrilateral. It's telling us what this angle is, so that's okay. And it's telling me what that angle is, so that's okay. First thing I'm going to do here is I'm going to look at parallelograms. Diagonally opposite angles are equal. So I know that that is 128 degrees. I also know that these two angles are equal. So if I now look at that, that's 360 degrees. I can do 128 add 128. So 16, 4, 5, 2, 360 subtract 2, 5, 6, 5, 4, 0, 1. So them angles together equal to 104. So I'm going to split that in two, giving me 52 degrees. So I know that's 52 and that's 52. And then that's all linked to the parallelogram. I know that that's a straight line angle. So straight line angles, 180 degrees. Subtract 52. So again, borrowing 8, 2, 1. So I know that's 128 degrees. It wants me to work out BAE. BAE. So I now need to work out this angle. So I've got triangle. Let's come out a little bit. So triangles equals to 180 degrees. I've got 128 and I've got 39. So let's add them together first of all. So 17, 6, 1. So then 180 subtract 167 leaves me with 13 degrees. So my final answer then, so for this angle here, is worth 13 degrees. Okay, so not angles on parallelogram, parallel lines as such, but we've got some of that parallelogram knowledge, angles on a straight line knowledge, and triangle knowledge. Okay, last one we'll have a look at together. So we've got parallel lines again from that first line. And again, we've got the arrows. We've got an isosceles triangle, meaning that these two angles are going to be the same because our arms are pointing down towards the feet. So I'm going to work out this angle first, which I know is 70. And I also know that's 70. And I know that because angles on a straight line are equal to 180. Let's bring that down. So I've dealt with that a little bit. I can also work out this one. 70 at 70 is 140, leaving me that angle there is 40 degrees. It's told me about that angle and I've used that. Find the size of angle FGD, F, G, and D. So I need this angle here. So now I'm going to look at putting this in. And I've got those two angles here are on alternative sides of my transversal line. So I've got parallel lines, a transversal line, opposite sides. So these are then got me an alternate angle. To go through my explanation, I would then put that I've got isosceles triangles. I then have to write it out. So I've got straight line angles are equal to 180 degrees. I've then said opposite angles, sorry, the two angles here are equal to each other on an isosceles triangle. Angles inside a triangle equals to 180 degrees, leaving us with 40 degrees for this one. And then the final explanation I would then write down is that alternative angles are equal in size. So because that's 70, that's also 70. And then I've got my answer. And then again, I'd have to just write each step down as I went through. Right, hopefully that's helped with a bit of alternative angles. Obviously there's some more stuff that you can have a go at with these ones. But again, it's those main things over: vertically opposite angles, straight line angles, alternative, corresponding, and that will get you everything you need to then get through. And very much the only rule we've got different, we've got straight line angles 180 degrees, corresponding equal in size, vertically opposite equal in size, and alternative angles equal in sides. Okay, so if we just go with that, jobs are good, and that will get us where we need to get to. Okay, bye.